The method of partial sums with rearrangement, presented by Simon Cox. We use the method of partial sums with rearrangement to analyse what happens when we rearrange or add two infinite series. The process works by taking a partial sum, rearranging it, and then splitting it into two series, the target and the remnant. We then analyse any patterns found in the series of remnants. An example of an interesting pattern found is this sum. When the limit is taken, the sum equates to half the natural log of 2. The derivation of this result can be found in the video about Dirichlet and the natural log of 2 being equal to half the natural log of 2. Let S be an infinite series such that S is the sum of its AN elements, and sigma of S be a rearrangement of S. The nth partial sum of S is the sum of the first n elements, and sigma of Sn is the rearrangement of these first n elements. We split the rearranged sum into two parts, the target sum and the remnant sum. The elements within the target sum are just elements that are within the target rearrangement. The remnant sum consists of all remaining items. Note that bracketed terms in the target need to be observed. For example, let our series be the sum of the natural numbers and our rearrangement be the grouping of the elements of the series into blocks of 3. Our first partial sum will be the first element of the series. We rearrange it and then we split it into the elements that build up the target series, and the remainder go into the remnant series. Here we can see there isn't a block of 3 consecutive elements of S, so the target series is empty and the remnant series contains 1. We move on to the second partial sum. Here we still don't have 3 consecutive elements being summed together, so our target series is empty still and the remnant contains the last 2. However, when we move on to the third partial sum, we have 3 consecutive elements, and when we split the rearrangement up, we have our first element in the target series and our remnant becomes empty. We proceed to the fourth partial sum. We rearrange it and then split it between the target series and the remnant series. The fifth partial sum, rearrange and split. The sixth partial sum, we rearrange and split. And this process continues until we manage to see a pattern within the remnant series. We'll now cover a more complex example. Let our series be the harmonic series and the rearrangement as follows. We'll take the even negative quantities and we'll take the absolute value and then subtract twice the negative value. We'll rearrange the positive terms together and the negative terms together, and we'll notice that the negative terms equate to the positive terms, and we'll group those together, and we'll find that this rearrangement of the series results in a total of 0. We now perform our partial sum with rearrangement. Our target series is going to be this. Our first partial sum is going to be 1. We rearrange this and then split into our target series and remnant series. Our second partial sum, we rearrange and we split into our target and remnant series. Third partial sum, rearrange, split. Fourth partial sum, rearrange, split. Fifth partial sum, rearrange, split. Sixth partial sum, rearrange, split. And you can see there's some sort of pattern building up with the remnants here. And this is why we use this method to analyse rearrangements of infinite series. This completes our introduction to the method of partial sums with rearrangement. See in the description below links to other videos that use this method to highlight errors in manipulating infinite series. These videos are based on a technical paper entitled Re-establishing the Additive Commutative Law for Conditionally Convergent Series. A link for this can be found in the description below. If you like this video, you may wish to subscribe to be notified when new content has been uploaded.